Imagine swimming in the ocean and suddenly encountering water that's not just warm, but boiling hot. The very phrase boiling oceans evokes images of a dystopian, steaming sea, perhaps a scene straight out of a science fiction movie. But how close is this scenario to reality? Let's dive into the facts. The term boiling oceans can be quite misleading. In truth, our global oceans are not turning into giant kettles on the stove. However, there are indeed specific areas where the water temperatures can soar dramatically, creating what might seem like localized boiling spots. These unusual phenomena are not the product of apocalyptic climate change or oceanic anomalies on a vast scale, but rather the result of natural geothermal processes occurring deep beneath the ocean's surface. These can include underwater volcanic activity and hydrothermal vents, which we will explore in more detail later in this video. So, while the oceans aren't boiling globally, certain spots tell a different steamy story. Did you know that some parts of the ocean can reach temperatures over 700 degrees Fahrenheit? It's true, and these figures are not just anomalies, they tell a tale of our ocean's hidden fiery nature. Deep beneath the ocean's surface, in areas most of us will never see, lie the extraordinary features known as hydrothermal vents and underwater volcanoes. These are not your typical hotspots. Hydrothermal vents, for instance, are fissures on the seafloor that emit superheated water, reaching temperatures that defy the surrounding cold oceanic depths. Meanwhile, underwater volcanoes spew molten rock and hot gases, creating an environment that can heat the water to boiling points and beyond. The hottest recorded ocean temperature, found at a vent in the Pacific Ocean, was a staggering 750 degrees Fahrenheit. Imagine, water hot enough to melt lead, all occurring naturally in the deep, dark parts of our world's oceans. These scorching figures set the stage for understanding the true nature of our seemingly serene oceans. Beneath the ocean's surface, hidden ecosystems thrive around what are known as hydrothermal vents. These remarkable features of the ocean floor are not merely anomalies but are key players in the ocean's complex ecological and geological ballet. Hydrothermal vents are essentially underwater geysers. They form along the Earth's mid-ocean ridges, which are expansive volcanic mountain chains beneath the sea. As tectonic plates diverge, cracks and fissures open up in the ocean floor. It is through these openings that seawater begins its extraordinary journey. The process starts when cold ocean water seeps deep into the Earth's crust. Here, the water becomes superheated, reaching temperatures of over 700 degrees Fahrenheit due to the intense heat from the underlying magma. But despite these scorching conditions, the water does not boil. The immense pressure of the deep ocean, which can be hundreds of times greater than the pressure at sea level, keeps it in a liquid state. As the water heats, it also becomes chemically enriched. Now imagine mountains that erupt under the sea. Beneath the ocean's surface, these submerged giants, known as underwater volcanoes, play a crucial role in shaping our planet's seascape. Let's dive deeper into how these fascinating geological features contribute to heating ocean waters and even crafting new seabed and islands. Underwater volcanoes, or submarine volcanoes, are formed by the movement of tectonic plates. When these plates move apart or collide, magma from the Earth's mantle forces its way up through the crust, reaching the ocean floor. Unlike their land-based counterparts, most of these eruptions are unseen by human eyes, hidden beneath waves and water depths. When this superheated magma makes contact with the cold ocean water, a dramatic interaction occurs. The water around the magma flash boils, creating plumes of steam and superheated water that can rise many miles up towards the ocean's surface. This process not only increases the temperature of the surrounding water significantly, but also contributes to the rich and unique ecosystems found around these volcanic sites. The creation of new seabed and islands is another fascinating aspect of underwater volcanoes. Over thousands of years, repeated volcanic eruptions deposit layers of lava and ash on the ocean floor. These deposits gradually build up, forming new underwater mountains or even islands if the topography reaches above the water's surface. Moreover, the interaction between the magma and seawater results in various chemical reactions. These reactions often release minerals and gases that are crucial for marine life, fostering unique biodiversity in these regions. The extreme conditions around underwater volcanoes support organisms that thrive in high temperatures and pressures, which are otherwise not found in other parts of the ocean. In summary, underwater volcanoes are not just natural spectacles of eruptions and lava flows, they are dynamic factories of geological and biological activity, playing a pivotal role in the formation of new seabed, islands, and supporting unique ecosystems. Underwater volcanoes dramatically sculpt both the geography and the temperature of our oceans. Let's zoom in on some real-world hotspots where the ocean truly boils. At these unique locations, the boundary between science fiction and oceanographic fact blurs intriguingly. One of the most renowned sites of seafloor drama is the Mid-Atlantic Ridge. This sprawling underwater mountain range, stretching down the Atlantic like the seam of a giant's baseball, hosts numerous hydrothermal vents. These vents, often referred to as black smokers, emit jets of superheated water that exceed 700 degrees Fahrenheit. The water doesn't boil due to the immense pressure at these depths, but the temperatures are more than enough to warrant the term boiling in a metaphorical sense. Moving westward, the Pacific Ring of Fire encircles the vast Pacific Ocean with a string of underwater volcanoes and tectonic boundaries. Here, the ocean floor presents a spectacular show of volcanic activity. The waters around regions like the Mariana Trench, the deepest part of the world's oceans, are paradoxically both icy cold and scaldingly hot. In these depths, magma from the Earth's core meets seawater, heating it up rapidly and creating an environment that seems almost alien. Another hotspot worth mentioning is the hydrothermal field known as Loki's Castle. Located in the Arctic mid-ocean ridge. Discovered relatively recently, this site features towering vents that spew out water hot enough to melt lead. The surrounding waters, dark and icy, contrast sharply with the fiery eruptions of the vents, creating a surreal landscape underwater. Further afield, near the coast of Japan, lies the Ihaya North Hydrothermal Field in the Okinawa Trough. Here, the interaction between volcanic activity and seawater has created a unique ecosystem. The hydrothermal vents support communities of organisms that thrive in extreme conditions, relying on chemosynthesis rather than photosynthesis to derive energy. These hotspots are not just curiosities, they're vital for diverse marine life and geological studies. Each site offers a glimpse into the dynamic processes shaping our planet from beneath the waves, highlighting the powerful forces at play within the Earth's crust and the ocean floor. What happens to marine life when part of their world is a boiling cauldron? Dive deep into the ocean's abyss and you'll find hydrothermal vents, spewing superheated water into the icy depths. These vents are not barren wastelands, but bustling ecosystems teeming with life forms that have mastered the art of survival under extreme conditions. Around these vents, unique communities thrive, anchored by bacteria that convert the toxic chemicals spewed by the vents into energy, a process known as chemosynthesis. These bacteria form the base of a food web that supports a variety of organisms, from tube worms to giant clams, which have evolved to not just survive but flourish in these harsh conditions. The existence of these hotspots also has broader implications for our understanding of oceanic health and climate. The heat and chemicals from the vents influence local water chemistry and temperature, which can affect ocean currents and ultimately, global climate patterns. Thus, these boiling points in the ocean remind us, life thrives in the most unexpected places, adapting in remarkable ways to extreme heat. Today, we've journeyed into the depths to uncover why parts of our oceans are boiling. Let's reflect on the fascinating insights we've gathered. Initially, the concept of a boiling ocean sounds like a myth, straight out of a sailor's tall tale. However, it's grounded in startling reality. We explored the phenomenon of surprisingly high ocean temperatures, not widespread but localized and intense. Central to this mystery are hydrothermal vents, these underwater fissures where seawater meets magma. Here, water temperatures soar, creating what can rightly be called an underwater inferno. Equally compelling are the underwater volcanoes, which act much like their terrestrial counterparts, but hidden beneath vast oceanic expanses. These geothermal giants significantly contribute to the localized boiling of ocean waters. We also touched on real-life examples of these oceanic hotspots and discussed their critical role in supporting unique marine ecosystems and influencing geological processes. So, the next time you dip your toes in the ocean, remember, beneath the waves there are places where the water boils, nature's own hot tubs.